ठीक है, पर अभी तो इसको थोड़ा ऐसे रख लेना यहाँ पे, ठीक, बस सही है.
So this session is, first of all, what this session is about. If you have, if you have no idea of what the things were mentioned in the document, it's okay, not a problem. The thing is, this session is about getting you to know what you're into, because in college you'll be attending classes and everything, but you have no idea where you're headed. As in, we all want to know that we are going to be programmers or we are going to be software developers or whatever. But what exactly is it? So talking about something like, so I thought I'll take an example of something which we all use every day. Facebook, for example. So how difficult is it? Suppose you want 10 people to, like 10 is a small number, 100 people to use Facebook. Okay, 100 people. So how much time do you think you will take to build something like Facebook, which is only going to be used by 100 people? And this is like a development works, you know, it's a you're going to develop a software, just like you're going to develop a web application, right? So how much time do you think you'll take if you're experienced enough? So the answer to that, to be honest, experienced Rails developer will hardly take like 2 or 3 days to build something like Facebook. But the thing is, about for 100 people, and here we are talking about billions of people, right? And then you'll ask, so Zuckerberg initially built it all on his own. But then eventually people came along, because initially they were able to handle 100 people, 1,000 people like that. So software grows, right? So then you'll say, okay, I'm into competitive programming, I'm into software development, I'm into Linux, I'm into all those things. So all of you have your own interests. And the thing is, even if you are not, let's say, so in college this happens, somebody with some other interest does well. You think, okay, should I get into it? That's the question which hops onto your mind all the time. Maybe if so that happened with me as well. So people are doing well in something, I also want to try them, but I tried it, then I failed. I'll say, okay, I don't. Then I realize I don't want to do it. So same way, there are many things that for everyone it happens. So but the thing is, everyone fits in somewhere. As long as you're interested, you're going to fit in somewhere. So for example, as I was talking about Facebook, if you're a competitive programmer, where are you going to land up in Facebook? Like, where exactly, what will be your role? If you're into Linux, if you're into networks and all those things, where are you going to land up in a company like Facebook? So it's in Facebook. If as I said, if you write for 100 people, you're going to write around let's say 1,000 lines of code, and an actual Facebook that we see will have around maybe somewhere around a million line of code. And you have like thousands of developers maintaining it. There's a whole pipeline which is set up. So there's someone. So you want to efficiently search something. So you have to write algorithms for that. Now that efficient search is going to work only on a box. So for example, you might have written some program online on a competitive program platform. So you are giving some input, and you are told to write an algorithm for that. And within the time frame, you have to execute it. But the input will be around 10,000 or maybe 1 million, right? But at Facebook scale, we're not talking about a million. We're talking about a billion or maybe more, right? So your algorithm cannot run on a single system, no matter how efficient it is. You have to have an idea. So 1 billion, to store 1 billion records, even you don't need one system. You need thousands of systems, and they have to be distributed across the globe. So that's the kind of scale we're talking about. So where do people fit in? So competitive programmers, for example, will be are potentially hired to write state-of-the-art algorithms. So they are given difficult problems, and they spend all their time trying to optimize the best way they can solve that problem. That's it. Their role ends there, and then they write code maybe in some language, C or C++, and then they make it work, right? But then comes in other people. For example, now that code has to be run across multiple servers and across multiple data centers and all that. So then other people come in, like Linux guys will come in. There'll be a deployment team which will come in, and they all will put in their efforts and to somehow scale the code, right? So that's another part. And then where application developers come in. So you have this Facebook website you open. What you click something happens. All that has to be written in terms of code, right? Even if it's going to be used by a billion people, the code has to be the same, right? So they need good developers who understand what does the user want, and then writing things in a good way. So they need people like that. So that there comes the application developer role, and then you have managing people. I know programmers hate managers, but they are the reason why companies work. If you go into the corporate world, you will see how efficient they are. I mean, you have to manage team of, like, here we are talking about 30-40 members, and we are talking about projects, and then nothing goes on, right? Nothing happens, nothing moves. But then there you're talking about thousands and thousands of people. You have to manage them, you have to, and then different teams, and then you have to think about everyone's interests. So it's like a very difficult job to do. And then programmers hate managers because managers make them do things, right? And programmers by default are like lazy, so they don't want to do anything. But the managers have to push, and that's a difficult job. And so that's where managing people fit in. And I'll tell you about, as I said, about competitive programmers' role. And same way, I'll talk about how Linux guys, play a very important role. Just yesterday in my company, someone pushed a single line of configuration change. They just modified a configuration file, one line of change. They just modified a value from 90 to, I think, 60 or something, and they saved $1,200 a day. So one line modification saves $1,200 a day. And we're talking about a company like mine, which is like, not compared to something like Facebook, it's like not even 1%. It's a very small company. And for that, a single line of change is saving you $1,200. That is because that person knew exactly what he was doing. He knew exactly from the beginning to the end, okay, so for that one line of change, he had to study through like 4-5 days, try to understand where things are going, what is happening, had to go through logs, terabytes of log, had to understand where exactly was the problem. And then he came to a conclusion, okay, that he has to fix it like this, and that worked. $1,200 a day. That's a big, huge saving. So that's where Linux enthusiasts, you guys need to know in and out of Linux, how things happen. So that's another thing. And then application developers, as I said. So ultimately, user, when they come to your platform, they don't care how efficient your algorithms are. If I want something, I want something. I don't care you're dealing with a billion records or a million records. I want it in 5 seconds. You have to give it to me in 5 seconds. So, but then to them, what matters is how I'm seeing the data. What is my experience? How am I, using the platform? So that's the reason why, to be honest, Orkut was initially much more scalable as compared to Facebook. It was much more efficient as a platform because it was backed by Google, and Google at that time had the best algorithm in place. But Orkut went down, right? Why? Because it was the application developers, the UI designers, the user experience engineers who understood what exactly user wanted, and they developed it, right? So they played their role. So what I'm trying to say here is that everyone fits in somewhere, and everyone has a very important role to play. So here, right now, you must be thinking that what would I do after graduation? You'll probably end up in a company or maybe start your own company, and so there it won't be about one line of code. A file of code or something. You'll have to deal with a huge code base. There'll be lots of people working with you. You have to understand what they are working on. So that's why try to when you're working on things, always think from a perspective that you'll be working in a team. Because you'll never be working alone, right? So that was one idea. And why is it important to write good code? I'll tell you another story of Netscape. Has anyone heard about Netscape? Netscape. So Netscape was this browser which came around in 90s, 97, I guess. 91. It was one of the first browsers to come along, and it was very famous. The reason why we have www right now is because of Netscape. Because Netscape changed the World Wide Web completely. They were the pioneers at it, and there were a bunch of school kids, college kids, who initially designed it. They wrote very nice code according to them. It worked well. People used it. Everything was fine. But the thing is, I'm sure you might have met people, okay, who are like this. You tell them, okay, this is not written properly. Maybe you should write it this way. Then you'll say, it's okay. I don't care. Those who can understand it will understand it. I don't mind it. Okay. What happened? An year down the line, they kept writing code, adding feature, and year after the main development, the code was so much complicated that they themselves could not understand it. And they decided to rewrite it. And at the same time, Microsoft came in the market, and there's a whole story if you want to read it. But the main reason for why Netscape failed was because of the bad quality of code they wrote, and they couldn't fix it. And Netscape went down badly. They lost to IE. So it's very important for organizations to write good quality of code. So whatever organization you join in, they'll always give you a manual of kind of code they expect, and then they'll have automated test cases which you will see the kind of code you write. So they always say it's okay if your code performs slow. We don't mind it. As long as it meets our user requirement, it's fine. But if your code is not well written, if it is not extensible, if it is not maintainable, we don't want the code. So that's how that's how it works, right? So yeah, so that was about about the whole software development cycle and where you might where you might end up and what you might do. So any questions on this? Anybody wants to know anything? Open up, just ask questions. It's no. Yes. Any doubts? No. Okay. Okay. All right. So that was just to give you an overview of the software there. Now coming to the tools. So we, I think I told about a couple of tools. No, more than that actually. We'll discuss Git, then we'll discuss VirtualBox, and then there's something called Vagrant. So don't worry about the terms. I'm not going to get into the intricacies of the tools. I'm just going to tell you the importance of those tools. Why are those tools important and what exactly they let us achieve? And then only you're going to appreciate and work with them, right? So talking about the first thing I'll start up with is Git. I'm pretty sure all of you have heard about Git multiple times, a lot of times, and well, it actually is the reason why we have Linux. Anyone knows Linux? Everyone knows Linux, obviously. Linux kernel is maintained in Git, and it has thousands of contributors, and that has been possible only because Git was there. All over the globe, they have people contributing. If Git was not there, the Linux wouldn't have been there, to be honest. So that's the reason why Linus Torvalds, who made Linux, he wrote Git actually because he wanted something like that. And actually, if you guys know, he was the one who wrote Git. So it was one of the reasons why he wanted to write Git, because it was getting difficult to maintain something like Linux, and yeah, SVM was getting problematic. Yeah, SVM was difficult to maintain. It didn't. It was not. He wasn't able. It was not addressing his use case, so he came up with Git. So why do we actually need Git? As I said, you'll be working in teams, and you'll be having thousands of people working on a single code base. So imagine you are here. So take an assignment that you worked on. Your assignment had 10 files or maybe 15 files, and all of it is here. So let's say this is a container. This is a box. Inside those 15 files are there, right? Everything is in there. Now you started working on something. You said, okay, I want to implement this particular feature in my project, in my assignment. If it was, and then after you modified 5 files, did some 50 lines of changes, you realize that it was crap. It wouldn't work. It is not going to work out. Now the problem starts now. You forget completely what were those changes exactly. You don't remember what 50 lines exactly you changed. You completely forgot what were exactly the files you changed. And then you try to come back, like you try to delete everything and somehow revert back to your previous state, but you fail. Because I don't know, it has happened to me a lot of times. Has it happened to anyone here? Like you try to modify something, it happens a lot of time. And you realize that you end up spending hours, to actually revert back, right? So you did some changes, your now file state is here, and then you just can't go back because it's very difficult. You can't manually go through all the files. This I'm talking about just 5 files. Imagine if you had 50 files and you modify 10 files and 100 lines, just impossible to get back, right? So that's one place where Git can be helpful, right? And then second, another thing will be you have group projects. We have group projects here, a lot of group projects. We have 5 people working on the same project, and in corporates we have thousands of people working on the same project. So with 5 projects also, I don't know how you guys collaborate right now. Copy paste in a pen drive maybe, is it right? How do you guys do your team projects? Copy paste in a file. So that's actually then Git is another alternative to that. So you have this is the state where you have all your 15 files. So this same state will go to all your team members, right? And then so suppose you have 4 people, all of you are the same state. Your team, this team member modified some file. So you have 15 files numbered 1 to 15, right? This teammate modified file number 1, and he modified line number 1 in it. This teammate also modified file number 1, but he modified line number 2 in it. and then they can merge the changes completely. Okay, they can all, whatever changes they did, they can merge into a single file. So they'll have the changes done by the, and then same way he worked on, let's say, file number 3, and then he came to this state, and then they all can merge together. Okay, if this is confusing, merge together isn't, what does that mean? Different state, is it sounding confusing? Is everyone understanding? Basically, state means what? I just modified a file. So right now, think of everything, all the files together, they make a state. As soon as I modify any file, I go to a different state, right? So I modified, this person modified file number 3, and then he came here. Now imagine in a real life scenario, what I would have done, I told, okay, give me your changes. What changes have you done? So what he'll do is, he'll give his entire code base to me, or he'll say, he'll just give me file number 3. I'll then have to give the pen drive to all the team members. Then all the team members have to individually update their code, right? So that using Git, you can actually solve this problem, that you can instantly pull the code pull the modifications that your team member has done. Now, if after modification anything is failing, you can always revert back to old state or anything. Okay, so that's in a nutshell. That's basically something Git is for you guys actually. For you, I mean that's what Git is. Apart from this, from Git, it has lots of other features. So which is not exactly important, as in important in a lot of ways, but then not important for you right now. For example, if someone wrote some line of code and it broke something, now who will take responsibility for who broke the thing? I mean, suppose your assignment was working. Suddenly, the moment you have to give demo to the professor, before that, finally your teammates completed everything and they changed the code on the pen drive. But then your code stopped working. The last time you guys synced together, code was working. But this time the code stopped working. How would you fix it? There's no way you can fix it. I mean, you have to again sit together, you're going to waste time, and then that's how you're going to fix it, right? With Git, you can instantly know, okay, this person made this line of change and this is breaking the code. You can exactly point to the line or different files on what changes exactly broke the code. And then you can instantly, within a second, come back to your previous state and you're good to go. So it's going to save time for you, right? And then if you have seen GitHub, how they do software development there, essentially this is my software repository. This is all files in some state. I'll fold it. So I'll clone the entire thing to my repository. I'll make some changes to it, and I'll say, okay, please merge my changes, right? So that's how GitHub works, sort of. I mean, in brief, not exactly this, but yeah, that's an overview exactly. And I'm not going to explain you the entire thing, but you get an idea why we would want to use Git. So no matter what you're interested in, you'll always use Git. So please get aware of it. Now coming to VirtualBox. Anyone has worked with VirtualBox? VirtualBox. Okay. So Linux users, how many people like use Linux on a regular basis here? Linux. Oh, awesome. Very nice. So I'm sure then if you're Linux users, then you might have come across this use case that you try to install something and then everything broke in your system. Like nothing is working, even the update stops working. I'm sure you've come across this use case, isn't it? And then if you're a Linux dev, if you're into Linux, if you're you always want to experiment, you always want to try things, and things keep breaking. And then what you do? You install the entire Ubuntu again, and waste your entire day, and that's how it works, right? So VirtualBox is like a what I'd say is a computer inside your computer. To be in simple words. So basically, if you're running VirtualBox, you can run a complete Ubuntu computer inside your laptop. So you boot in your laptop, just like you run a Chrome application. Same way you run VirtualBox. Inside that, you can run any virtual machine. So by machine here, I mean an operating system. So you can run Ubuntu, or you can run Fedora, or you can run any operating system that you want. Now, coming to the benefits of it, when you're running Ubuntu, inside Ubuntu you can run Windows. Suppose you want to test out some Windows applications in both Ubuntu and maybe Windows and Fedora or whatever platform. So you can instantly create a virtual machine and test out the application in that. And then suppose things broke, you can instantly delete the virtual machine and create a new one. But it has features like snapshots. So for now I created a virtual machine. So basically I have a new laptop in here, completely everything is configured. Now I install applications onto it, things are working, okay, I take a snapshot, as in take a picture of how exactly my machine is, save everything. Now Then I say, okay, I'll play around with it. I'll experiment. If things work out, very good. If they don't work out, something fails, I can instantly roll back to my previous snapshot. That's one thing. And coming to next thing is, yeah, isolation is also one thing. So here, how many are interested in pen testing here, security and all those things? Okay, so this is like a very nice tool for those guys. So what you can do is you can emulate a a virtual machine which is vulnerable, which has security vulnerabilities, and then you try to somehow exploit those vulnerabilities. So you can create virtual machines online. If you go you on different websites, you get vulnerable VMs. So right now there's a vulnerability which has come. I don't know what's the name of this. Meltdown Inspector. So they haven't released the exploit for that yet. But once they release it, you can actually create a virtual machine and test out if you're able to exploit some vulnerability using that. So just an idea I'm giving. So that way it can be helpful for you. And then so that was about VirtualBox. And then there's a tool which you might have heard of, like if you're into GSOC, you might have heard about it, Vagrant. So it's just a fancy name for something. Yeah, it's just a fancy name so you have a GitHub project and you want to install it and test it. I'm sure it's a pain. You have to install a lot of libraries. You have to configure a lot of files. Isn't that painful? It takes for some softwares it takes days. I've been through it. Like I was trying to configure some software. It took me a week around. I don't know. So it's a very painful process. And what if I say that you can just avoid all of it and run an application like 15 minutes? So that's the thing Vagrant is. But that is if the software if the GitHub repository provides you the Vagrant something. There's the Vagrant file. So what is exactly Vagrant? To give you an idea. So you have VirtualBox. In VirtualBox you create virtual machines, right? And you take snapshot of it, right? And so how do you create a virtual machine? You log into the virtual machine, just like you're using a computer. You use your computer, do updates, install everything, and take snapshot of it. With Vagrant, you write scripts for all those things. So instead of doing that from the UI or the terminal, you write a script. So basically, you get a base Ubuntu installation, and then you write scripts to install all of that, and everything will work fine. Then some other developer can take your script and run it in a fresh Ubuntu installation, basically fresh Ubuntu VM, and you'll get exactly the same setup that you have, right? So that way, what happens? I don't have to go through this pain of configuring things on my system. And maybe I'll have something configured a different way, but it requires to be configured in a different way. But if I have Vagrant, then I can exactly clone what you have. I mean, is that clear? Does that give an idea? So imagine basically every time you get a fresh laptop, and then somebody gives you a set of scripts. Basically, not set of scripts, just one script. You run it on the laptop, and you have the application up and running. And for sure the script will run because it has run for him on a same laptop. So it's basically a fresh same laptop. So it's going to run on your machine, right? So that's basically Vagrant for you. And also with Vagrant, if I created a VM, I can create a snapshot and upload it on a repository, and others can also pull it. Apart from this, except for this, apart from the script file, if I don't want to write the script, I just create the VM myself and I upload it on the repository, and then anybody can use it, pull it and use it, right? So it's just a fancy VirtualBox, that's it, right? So, but it is going to save a lot of time for you, okay? Then coming to the buzzword these days, basically Docker. Has anyone heard about Docker? Maybe the first years wouldn't have, but the second years would have. So Docker is a lightweight alternative to virtual machine. So virtual machine is like, if you want to install a virtual machine, you need to have a lot of storage. I mean, for 2-3 GB for installing the operating systems. Just like you have your laptop, whatever space you need for installing the operating system, same way you need storage for installing a virtual machine. So it's kind of, it takes a lot of time. If you want to give your, the VM to your friend, you have to copy, paste, and then it will take like 10 GB or 15 GB of copy, and it will take a lot of time, right? So with Docker, it's like they have made this thing, they have just made it very lightweight, as in you have a lightweight virtual machine. So basically, you use the same operating system. So okay, anyways, I don't think we will get into it. Let's leave Docker for now. But it's if anybody is interested in exploring, you can go and explore it on your own, because it's difficult to explain Docker right now to those who are not aware of operating systems. So I cannot explain to that. So that's why please, if you're interested, maybe second years, we're going to have some sessions as well on Docker. They're scheduled, so if those who are interested can attend the session. Now, so we are through the software development lifecycle part, and we are also through the tools part. So, any questions on this? Any questions? Anybody has used VirtualBox? You were telling, can you VirtualBox? So, what have you used it for? VirtualBox?
I wanted to install Arch on my system. I wanted to be sure that I do it right.
Okay.
I was not using I was not using antivirus or something, so I just installed it on VirtualBox multiple times.
Okay.
Messed it up multiple times, and then I did it on my system.
Okay, so that's a very good use case of VirtualBox. Anybody else has used VirtualBox? So what have you used it for?
I use it because I wanted to check if my program ran on Windows and Ubuntu. So that means.
So you create a virtual machine. Alright, virtual machine and VirtualBox. Anybody else?
My Wi-Fi wasn't working on the Ubuntu, so I installed it.
Okay. Alright.
Because of some drivers missing on my laptop.
Okay, nice. Another use case. Anybody else? What have you used it for?
I actually was experiencing kernel freeze on Windows.
Okay.
So I had to use it in Windows.
You had to use it in Windows.
I had to use it in VirtualBox,
So you installed VirtualBox inside Windows and then you install Ubuntu.
Yeah.
So your primary OS is Windows.
yeah, but I installed Fedora.
Okay, Fedora was working. Okay. And also, so you have, if you have, I think you must have faced this as well. If your app get upgrade, sometimes your computer stops booting altogether. Has that happened? And you go down to the lower kernel versions, and then you can always boot the laptop. Does it happen with the new one?
Yeah, for me, there was a kernel freeze on the Mac.
Okay.
Kernel panic on the Mac when I did apps upgrade.
Okay, so this happens quite a lot. So that's why what people do is to test out the newer kernels, they always test it on the virtual machine like that. So yeah. Okay, so the tools part is over. If anybody has any questions, so if anybody has tried using this tool for something and they got stuck or they have a doubt on how they might have, how they might want to use it, you can always ask me. So any questions? No? Yes. Why is it always one-way session when I'm here? I'm like always here to talk to you guys, and it's always one-way session. So, now a few things which I want to add personally to this is if you want to speed up your development or if you want to be more productive, have a good terminal environment because I've been through in the past 1 week I've been very unproductive because of my terminal environment. So if you have a good terminal environment, you're going to speed things up a lot. So get accustomed to your terminal shortcuts and all those things. You'll see this applies mostly to the Linux guys, not to the other people. So I've seen people who are like they just don't look down on the keyboard. Never. They just keep putting shortcuts and everything, and they'll do things fast. So what I'll do in 1 minute, they'll be able to do in like 30 seconds. That's how. So that's configure shortcuts for everything. एक बंदा है, he has written alias for git pull gp. Okay, the git pull origin master. उस command के लिए written alias gp. Okay, so every time he has to pull the code, he will do gp. And same way he has written aliases for everything on his system. So many aliases, like 150 aliases on his system. So that's and aliases for everything. Aliases, what are they? Aliases. So basically, you write a short form on your Linux machine. On terminal, you type a command, right? If you want to run Firefox, let's say, from your terminal, you'll type Firefox on your terminal. So you can write an alias f equal to Firefox. So if you type f, Firefox will start. So it's like shortcut for everything. Okay, and so that's one thing. And then this was how many of you have used SSH? SSH. So what exactly is SSH? Can anyone tell me?
Secure circuit encryption.
Why is it used?
So it's basically used to access a remote machine. Log into a remote machine.
Okay. So SSH, go read up about it. Those who don't know, please, it will be really useful. Now the last part of the session is about giving you an overview of. So these days there's a trend. We don't see the old executable files on a system. Like suppose if I want some application, I'll always get an online version of it. Even now they're shifting Photoshop as well to online. They're trying it. Adobe is trying to move to Adobe Cloud. there you log into from a web interface. You get to modify photos just like you use the Adobe's suite. Yeah. So the thing is, it saves companies from obviously piracy because everything is on cloud. Secondly, it makes the basically so okay, the thing is everything is getting into web. That's the whole point I'm trying to make. We are shifting from the time where we used to have Java softwares written and running on different systems. Everything is on the web. So in hospitals also, if you go, they'll have a web interface, and through the web interface only they'll manage the bills and everything. The thing is that it's very easy to write web applications, and they work really well as compared to the traditional software. And then suppose, and they don't have the compute limitations. So suppose even if I have 512 MB on my laptop, I can still run a Chrome, and I can have a computer which has very high, a server which is very high end, and on that I can run the important code. This will be just the dumb terminal sort of thing. So web is making everything is shifting to web. That's the point I'm trying to make. So what I was telling you is that you must know a few basics of how the software runs on the web, right? So let's take an example. So I'll just give a maybe 5 minutes thing on it. So that'll be short. So if you want to run, let's take an example of some software like Academia, for example. Academia, right? So what is it? IIITB.in. You open this website. You type this in your browser, and then you get to see your mark sheets and all those things, right? And so this portal, somebody from the admin uploads the information on it, right? And you essentially get to access it. Suppose somebody told you that you have to make something like Academia, and you have to deploy it completely so the students use it. Okay, you got the use case, the problem statement, right? You have to develop something like Academia, and you have to deploy it. Like people will be using it. So if I type IIITB.in on my web browser, students will basically see the login interface. So you have to build a complete software. Okay. So what exactly happens when you type IIITB.in on your browser? Any idea? What happens basically? Okay, skip that part. You want to make Academia, right? What would be your first step? I gave you the problem that you have to make Academia. Okay, IIITB.in you have to make. How do you start? You pick a language, maybe Python, or maybe you pick Ruby or whatever. You pick a language, right? You write code for it, right? And then you test on your local machine if everything is working fine. Correct? Everything goes on well. Very good. Everything is working fine. Now, next step is to make users use it, right? What would you do? Anybody has any idea? Can anyone tell? This developed thing was working perfectly on your machine, but now it has to be used by users, actual users. What goes on after that? What happens? How do you deploy? That's the thing. How does it work? How does the whole not about the deployment process, but still, any brief, any idea? Or you wrote a very nice piece of software, which maybe let's say you wrote a very nice compression algorithm. Okay, what it does is you give an image, it will compress the size, it will resize the image, but it will maintain the quality of it. Like, you know, the quality will be very nice, just that image will be very compressed. It's a very nice algorithm. You wrote it on your system, but now you want everyone to use it. How do you go ahead?
First of all, you need to make the dependencies like on whatever the code you've written. Okay. What all other people need to.
So let's take this image example that I said, and the other example is Academia. So we have two things here. So we have to ultimately ship it to people. I mean, people have to ultimately use it. Okay. So image and Academia, right? So image mein you were telling them dependency.
Yeah, it's like you need to be able to like list out the stuff that other people need to install. That does that's not by default. So
People don't have to install it. People have to use this software. I mean, I have my algorithm. I don't want to give my algorithm to them. I'm not giving because I wrote a very nice algorithm, let's say. But I want them to try it. I want them to use it. So they'll put an image. I'll compress and give them the compressed image. Okay. And so that's so yeah. So how do you proceed? Any idea?
So this will be running on a server, right?
This has to
Yeah.
run on a server. Obviously,
So-
so you have to run it.
Yeah, so on that server you need those dependencies to run for that piece of code to run.
Okay.
So that's what he's saying.
Okay, right. That is
No, I
fine.
thought it was going to be shipped everyone. First of all, you
You
need to
should
be
be
able to
handling
access
your-
images so that people can send images and stuff. for
So
the
maybe what you'll want is like if you have a website, so if people come onto your website, they upload the image, and then you get the image, you run your algorithm, and return to them the compressed image, right? Isn't that a good idea to give them access to your code? They don't get to see your algorithm, and everyone in the world gets to try it out, right? Now I'll give you a hint that okay, you have to ship to web application, and now how do you go ahead from here? So you have to essentially deploy web application, right? And so next step, what would you take?
So if you write the code for getting the image and
So you have to write a web application.
yeah.
So you wrote a web application as well. Now next step.
You get a URL, the domain names and
Okay,
all.
correct. Now you buy a domain. So I have my awesome website, awesome.com. Let's say I bought a domain. I had okay. Sorry, my handwriting is very bad. So I bought this awesome.com. Now I have a domain also. I have my algorithm. I have a web application written. Everything's done. Now next step,
Link it.
link it. So link the domain to what?
The
Server,
public
server,
IP, public.
So okay, I have web application the code, right? So right now the code was running on my laptop, and I am the only person who is able to access the code of web application. But I have to give the access to that code to just the running instance of the code to everyone. So I have to deploy it on a public system or maybe on a public server. So I find out a cloud kind of thing like AWS or DigitalOcean. I mean, these are the words. Just keep it in mind. DigitalOcean and AWS, these are cloud services where you can rent servers. So right now I have my laptop, but I cannot allow everyone access to my laptop. But I have a machine which has a public IP. Anybody can actually query it. Like, I can access it. So I have to get a cloud machine sort of thing. So I get a server now. Also. So what do I have now? I have the algorithm, I have the web application, I have the domain, and I have a server. Now next. Is that it?
She resolved it, the domain to that.
Yeah. Okay. So that's that's basically it. So if any of you want to deploy a web application, what I'm trying to tell you here is if you want to deploy a web application, this is all the things that you need to know. You need to know what is domain. You have to buy a domain. Then you have to get a server from somewhere. The server should have a public IP. Remember this. This is very important because computers talk by IP, right? And so if your computer wants to talk to any computer in the world, it has to have a public IP. Right now, each one of you in private network, we have a private IP. That's the reason why we can't talk to all the computers in the world. But if you want to have a computer which can talk to anyone in the world, you need to have public IP. So if you did the OpenVPN domain and you have your algorithm, you have your web application. Now you can just go and install your web application on this server and map your domain to this public IP, and then people can start accessing your awesome application. Right? That's pretty much, and the same thing applies to academia as well. You develop academia, you got the domain IIIT, you got a public server, and you map it, right? So got an idea, right? That's the reason why I told you guys to make the blog thing, So you'll get an idea of how this thing works. That was the main motivation behind it. So who deployed the blog? Anybody deployed actually their own personal blog? Very nice. So how did you do it?
I used Deccan. I thought I'd do it from scratch.
So you did on GitHub or you?
On GitHub personally, but I used Deccan instead of doing everything.
You have your own domain right now, or on that?
I think with GitHub you can get your own custom domain.
Yeah.
I think
that will be .github.
Right? No, that's for the project. Right? I think you can customize domain name.
No, you
It
cannot.
be username.
You can
Username
put your
dot-
own
dot-
domain.
By default, right?
.io.
Yeah.
Me will be fine.
Yeah, otherwise you can use your GitHub student pack to
Oh,
get
yeah.
a .me.
It's
Yeah, try getting your own domain and maybe put up and use that domain like keep your personal domain or something. So yeah, that's another piece. So any questions on this part? I expect each one of you see it is always very good to have an online presence. Okay, so as a developer, even if you don't have blogs to write, just put your CV or some information about you. Whatever projects you make, write some short write up about it, and it is going to help you in the hiring. If you're in interviews, if you have a website or something, people are going to actually look up to it, right? So it will be helpful for you. You have 3-4 years right now. I'm sure after 5 years you're going to have a very good set of articles to have on your website. It's going to help a lot. So please do that. Please, yeah. So मेरा blog. Okay. So I write this blog. I started like 2 years ago. The way I work right now is if I'm what if so it's like a blog for me is not a waste of time in a way that if I'm going to work on something, I keep a tab open like on my other monitor. Whatever I'm working on, I copy paste the commands or copy paste what hacks did I make or what small things did I do to make this thing work. And then at the end of the day, I compile it into a blog. I just have to modify a few lines. So while I'm working on something itself, I work